Let j sub 5 equal the set 0, 1, 2, 3, and 4, and define functions f from j to j5 and g also from j5 to j5 as follows. For each x in the set j sub 5, f of x equals x plus 4 squared mod 5, and g of x equals x squared plus 3x plus 1, all mod 5. Is f equal to g? Now, two functions are equal to each other if they have the exact same input-output correspondence. So every input that corresponds to an output in f should also be an input that corresponds to the same output in g, and vice versa. So that means if we draw their arrow diagrams, we should get pretty much the same picture. If we write the set of ordered pairs in this function, we should get the same sets. These are all different ways to show that these two functions are in fact the same. And to show these functions are the same according to the definition provided in the book, we're going to have to plug in every input from the domain of each of these functions into these functions to see if we get the same outputs in both functions. For this, I'll draw a table. Our inputs are 0, 1, 2, 3, and 4. So let's start with f of 0 is what we get when we plug 0 into the function f. 0 plus 4 is 4, and then 4 squared is 16 mod 5 is 1. So f of 0 equals 1. G of 0 is 0 squared plus 3 times 0 plus 1 mod 5, which is also 1. So that looks good so far. Let's continue. F of 1 is 1 plus 4, which is 5. 5 squared is 25 mod 5 is 0. G of 1 is 1 squared plus 3 times 1 plus 1, which is 5. 5 mod 5 is also 0. And here we get the same outputs again. F of 2 is 2 plus 4, which is 6. 6 squared is 36 mod 5 is 1. And then G of 2 is 2 squared plus 3 times 2 plus 2, which is 11. And 11 mod 5 is 1. And so those outputs are the same. F of 3 is 3 plus 4, which is 7. 7 squared is 49 mod 5 is 4. G of 3 is 3 squared, which is 9, plus 3 times 3, which is 9, plus 1, which is all together 19. 19 mod 5 is also 4. And lastly, f of 4 is 4 plus 4, which is 8. 8 squared is 64 mod 5 is 4. And g of 4 is 4 squared, which is 16, plus 3 times 4, so plus 12, which is 28, and then plus 1, which is 4. 29 mod 5 is 4. So for every input in the domain of both f and g here, since they're the same domain, they have to be the same domain in order for them to be the same function. For every x in the domain of our function, f of x equals g of x. And so by definition, these functions are the same. Thanks everyone, and I'll see you in the next video.